Hey everyone, this is a video just going through the keys for assignments 16 and 17, just a few of the problems. This is assignment 16, number 2. You can see the table has been completed, and when you're calculating who you think will win in the long run, it's essentially the one that wins more often. So here we could see that blue wins more than green. It's 18-15 with 3 ties. So blue, because they then have the higher probability of winning each round. So in the long run, they'll win more. Specifically, suppose you tossed 36,000 tosses. We can calculate a prediction of how many we would expect blue to get. And that would just be take the probability, which is 18 out of 36, 18 blues out of 36 total possible outcomes, and multiply that by the number of tosses. Do that calculation and you get 18,000. The Monty Hall problem, for a picture, I was looking for something like this where you don't have to color code it, or, I mean, there's lots of options that were fine. But to demonstrate this problem, there are 10 doors, 9 of which have a goat and 1 a car. And the orange represent the initial guess. Sorry, not the orange. The blue represent the initial guess, and you're picking 2 doors. So there's randomly 2 doors picked here. Obviously, we didn't pick the goat in this example. And then the orange, the host reveals 6 doors. So those are all opened, and those should all have goat because the host will not open a door that has the car. So we have 6 revealed goats. And then the choice is to keep those 2 blue doors or switch to one of the white doors. And the probabilities are based off of this game. So in part B, what is the probability that their initial choice contains the door with the car? Well, they get to choose 2 doors out of 10. So we can calculate that 2 out of 10, or 1/5 chance of winning. And for part C, the probability that their initial choice does not contain the door is 8 out of 10, right? There are 8. It's kind of the opposite, right? So those 2 questions will always add up to 1. So 1/5 plus 4/5 equals 1, okay? And then the more complicated one is, this problem didn't ask for this, but I thought I would go through and explain how to figure out the probability of winning if you stay and winning if you switch. Okay, so the probability of winning if you stay is the same as part B. You have a 1 in 5 chance of winning if you stay. But what about winning if you switch? So we use a little rule in probability, the multiplication rule, because there's actually 2 probabilities at play. To win if you switch, first you have to pick 2 doors that do not contain the car, right? So that's part C. What is the probability that your initial choice does not contain the car? And we've already calculated that as 4 out of 5. But then you're going to switch and you get to choose one of the 2 remaining doors. One of them has the car and one does not. So the probability of that when you switch is 1 out of 2. There's 2 doors to choose from, one has the car. So for both of those probabilities to happen, you multiply them together. So when I do the calculation, I take the 4/5 times the 1/2, which is 4/10, or reduces to 2/5. So the probability of winning if you switch is 2 out of 5. The probability of winning if you stay is 1 out of 5. So in this example, switching is better. It's slightly better. Well, I guess double, right? 20% versus 10%. Or no, sorry, 40% versus 20%. So, I mean, you double your chances by switching, okay? Even though both are less than 50% chance of winning this game. Okay, let's jump to the next assignment, which this one, there were some problems that maybe were a little harder than I had anticipated. So if you see your grade for this assignment, I didn't grade it as harshly or as thoroughly as I have been in the past. So you may want to still check this key because you may have gotten credit for an answer that wasn't entirely correct. So definitely look at the key for problems going forward. Number 1 is one of those. So the first two, A and B, were pretty straightforward. The probability that you get a red ball is 3 out of 12 because there's 3 red balls out of a total of 12. And then not a red ball is 9 out of 12, all of the other balls. And then we got to part C, where now you're selecting 2 balls. What's the probability that they're both red? And my suggestion was to make a list of all the possible outcomes. Well, it just turns out there's lots of them. There are 66 possible outcomes, right? 66 ways to select 2 balls. And here I have listed them. I listed them in sort of a systematic way. I started with the 1 red ball and matched it with all of the other balls. And then I matched the red 2 ball with all of the other balls, matched red 3 with all of the other, right? But notice here, I'm not going to repeat what I've already done. So I start red 3, G1. I've already done red 3, red 2, because the order here doesn't matter, right? So I didn't include that in that list, etc. And you know what this turns out to be and feels like is the handshake problem, right? It's kind of like these balls are shaking hands with each other. Okay, so we're actually calculating a little handshake problem. 12 balls, how many ways are there to match 2 together? And so that's 11 plus 10 plus 9, all the way to 1, which equals 66. So there are 66 total possible outcomes, 3 of which, right there, those 2, and then this one, 3 of which have 2 red balls. So the probability is 3 out of 66, which reduces to 1 out of 22. That's the answer for that one. So if there were a few students that got that, which was awesome. If you didn't, check out this one, that will help. And then the dice one was what we've done in the past. So it's similar to the last assignment. So I don't really want to go through that again. Let's get finally to the other Monty Hall game. We'll go through another one of these. So this one has 20 doors. You initially select 2, so I randomly chose 2, the blue, and then 16 of the doors are revealed. So the orange are the revealed. Remember, the host cannot reveal a door with the car. So at this point, either you've chosen the car or you can switch to one of the remaining 2 doors that has the car. Okay, so because there are 20 doors and you choose 2, the probability that your initial choice contains the car is 2 out of 20, which reduces to 1 out of 10. And then the probability that you did not choose the car is the opposite of that. So 18 out of 20, which reduces to 9 out of 10. Again, these two add up to 100%, 10% versus 90%. Okay. And then the probability of winning if you stay with your initial choice is the same because you have to choose it on your initial choice to win. So that's still 1 out of 10. And then E has this multiplication similar to we did in the last assignment. The probability that you do not get the door, the car on your initial choice, which has to happen in order to win if you switch, right? You do not want to choose the car on your initial choice. The probability of that happening is 90%, 9 out of 10. But then you do a switch and you only get to choose one of the 2 remaining. So if you've successfully not chosen the car on your first, now you have to choose the car on your switch. And there's a 1 out of 2 chance for that happening. So multiply those 2 probabilities together and you get the final answer, 9 out of 20 or 45% chance. Still better than the 10% chance of staying. So here in this version of the game, you want to switch because that probability is higher. And that's that. Okay, so hopefully that helps to clear some of those problems up. And if you have any further questions, please feel free to email me and I'll respond as soon as I can. Okay, thank you very much. Talk to you later. Bye.